In this lesson, you will learn how to add and subtract fractions. For the first 10 problems, all of the denominators will be the same. So when you're asked to add 3/7 plus 2/7, since both of the denominators are 7, we can write this as one fraction, 3 plus 2 over 7. The denominators don't add together, and the answer is 5 over 7. For number 2, 4 over 9 plus 11 over 9, both denominators are 9, so we would take the numerators of 4 plus 11 over 9, add the numerators together, and we get 15 over 9. Now in this example, when I write the prime factorization of 15 and the prime factorization of 9, since they both have a factor of 3 in common, they cancel, so that the final answer is 5/3. Now this can also be written as a mixed number since the numerator is larger, and to change 5/3 to a mixed number, I divide 3 into 5. 3 goes into 5 once, with 2 left over. So 5/3 is the same as 1 2/3. For number 3, -3/5 plus -2/5. Both denominators are 5, so I can write this as -3 plus -2 over 5. And if we take -3 plus -2, we get -5 over 5. And anything over itself is 1, but because the numerator's 5 is negative, the final answer is -1. Now for number 4, we have two mixed numbers, -6 1/12 minus 3 5/12. So to subtract these mixed numbers, the easiest way will be to change them as improper fractions. So 6 times 12 is 72. Add the 1 and we get -73 over 12. And then 3 5/12, I take 3 times 12 is 36, plus 5 is 41, so we have -41 over 12. Both denominators are 12, so I have -73 minus 41 over 12. -73 minus 41, if I do keep change change, it's now -73 plus a -41. Which is equal to -114 over 12. So to simplify -114 over 12, I write the prime factorization of both numbers, so that -114 is -2 times 3 times 19, and 12 is 2 times 2 times 3. The 2's cancel, and as an improper fraction, -3 times 19 is -57 over 6. But then I can convert this into a mixed number, and 6 times 9 is 54. So negative 114 is negative 2 times 3 times 19, and 12 is 2 times 2 times 3. I can cancel the 2's and the 3's, so that as an improper fraction, my answer is negative 19 over 2. And if I convert this into an improper fraction, 2 divides into 19 9 times, and when I subtract I have a remainder of 1, so as a mixed number it would be negative 9 and 1/2. So both of these answers are correct. For this problem, the negative 9 and 1/2 would be a better way of expressing your answer because the original question fractions were as mixed numbers. For number 5, 1/3 minus a negative 2 2/3. So we have 1/3 minus, if we change negative 2 2/3 to an improper fraction, 2 times 3 is 6, plus 2 is 8, so we have 1/3 minus negative 8/3. The denominators are the same, 1 minus negative 8 over 3. If we do keep, change, change, the two signs that are negative change to positives. So that we have 9/3, and 9 divided by 3 is just 3. For number 6, negative 3 7/8 minus 1 2/8. So I take 3 times 8 is 24, plus 7 is 31. So I have negative 31 over 8 minus 1 times 8 is 8, plus 2 is 10. So I have 10/8. Both denominators are equal to 8, so I have negative 31 minus 10 over 8, and negative 31 minus 10 is equal to negative 41 over 8. So as an improper fraction, the answer is negative 41 over 8, but if I change this to a mixed number, 8 goes into 41 5 times, and I have a remainder of 1, so this can also be written as negative 5 1/8. For number 7, even though this problem has variables, we always look at the denominators first. And since both denominators are 4 and we're adding them together, this problem is just 6x plus 12x over 4, and 6x plus 12x add to 18x. So 18x over 4 is the fraction, but not the final answer, because 18 and 4 can reduce. So I take 18 and write the prime factorization, and I take 4 and write the prime factorization. So if I expand out 18x, I have 2 times 3 times 3 times x, and then 4 is 2 times 2. The 2's cancel, and I multiply together what's left, and I have 9x over 2. These problems with variables you usually don't see written as a mixed number, so I will leave all of the problems that are variables, or that have variables, as improper fractions. So for number 8, we have 3 fractions, but again, all the denominators are the same. So we have negative 4x minus 3x plus a negative 8x all over 9. And if I write down negative 4x minus 3x plus negative 8x and show the work underneath. I start from the left, taking two numbers at a time. Negative 4x minus 3x is negative 4x plus a negative 3x, which is negative 7x. And if I add two negatives, negative 7x plus negative 8x is negative 15x. So I can rewrite this as negative 15x over 9. And then I want to take the two numbers of 15 and 9 and write their prime factorization. So that I have negative 3 times 5 times x over 3 times 3. The 3's cancel, and I multiply together what's left, which is negative 5x over 3. For number 9, negative 4 over 8x minus 12 over 8x. So both denominators are 8x, so I have negative 4 minus 12 over 8x. In the numerator, if I follow keep, change, negative 4 plus negative 12 changes to negative 16x, or negative 16 over 8x. And since I can take 8 and just divide it into negative 16 evenly, I don't need to write the prime factorization, although it wouldn't be wrong if I did. I have negative 2 over x. And the last problem with the same denominators is 5 over 6y minus negative 9 over 6y. So we have a 5 minus negative 9 over 6y. And if I follow keep, change, 5 plus a positive 9 is 14 over 6y. So 14 and 6 will have a factor in common, so if I break up the two numbers as their prime factorization, 14 is 2 times 7, 6 is 2 times 3, the 2's cancel, I multiply together what's left, and I have 7 over 3y. Now the rest of the problems will have different denominators, but the directions are the same, to add or subtract and write each answer in simplest form. So the first thing I want to do is I want to rewrite 4/5 minus 3/2, and then what I want to do is find what's called the least common denominator. And the least common denominator is found by taking my denominators of 5 and 2 and just writing out the first 5 multiples of each. So for 5, I have 5, 10, 15, 20, 25. And for 2, I have 2, 4, 6, 8, 10. The smallest number that they have in common is 10. So that means that the least common denominator, just abbreviated LCD, is equal to 10. So once I determine the least common denominator, on my 5 list, 10 is the second number, so I multiply 5 by 2 and the numerator by 2 as well. On the 2 list, 10 is my fifth number, so I multiply both the numerator and denominator by 5. And by doing this, I change my fractions to 8/10 minus 15/10. And now it's the same as the first 10 problems. I can now write this as 1 fraction over 10. 8 minus 15 is negative 7 over 10. For number 12, I have 5/8 plus negative 4 over 15. So I start by writing the multiples of 8, and then I'll write the multiples of 15. I usually start with the first 5, and if I don't have a match, I'll expand the two lists or only one of the lists. And if I look at these two lists, I don't have any number in common, so I'm going to expand the top list because this one only ends at 40. So my next multiple of 8 would be 48, then 56, then 64, then 72, and then 80, and I'll go a couple more, 88, 96, 104, 112, and 120. For the 15 list, hopefully we'll get a match. And it looks like we have a match with 120. So that means that the least common denominator is equal to 120. So if I look at the list that has the multiples of 8, if I were to count all of these numbers, 120 would be the 15th number on this list. That means that I multiply 8 by 15 and its numerator by the same value. If I look at my list of the multiples of 15, 120 is the 8th number on the list. So I multiply the fraction that has 15 in the denominator by 8. So that my new fractions are 75 over 120 plus negative 32 over 120, and 75 plus negative 32 is 43 over 120. For number 13, I start by rewriting these two mixed numbers as improper fractions. So 15 times 6 is 90. Add the 1 and we have 91 over 6 minus 7 times 10 is 70. Add the 3 and we have 73 over 10. So the denominators are different, so I start by writing multiples of 10 and 6. And for 6, I have 6, 12, 18, 24, 30, and 36. I usually stop at 5 or around 5, or if I get a match, and if I don't have a match in my two lists, I just expand the lists. And on this one, I'm actually going to stop right here because I see that 30 is the least common denominator. And on 6's list, 30 is the 5th number, so I multiply the numerator and denominator by 5. And on 10's list, 30 is the 3rd number, so I multiply the numerator and denominator by 3. So that I have 455 over 30 minus 3 times 73 is 219 over 30. And if I take 455 minus 219. 455 minus 219 is equal to 236. This answer, though, will reduce. So I want to write the prime factorization of 236, and if I divide 236 by 2, I get 118. And if I divide 118 by 2, I get 59, which is prime, so my prime factorization for 236 is finished. For 30, I take 2 times 15, and then 3 times 5, so that I can rewrite my answer as 2 times 2 times 59 over 2 times 3 times 5. Only the 2's cancel, so that I end up with 118 over 15, or I can change this to a mixed number, and 7 times 15 is 105, and when I subtract I get 13 left over, so that this can also be written as 7 and 13 over 15. So for number 14, I will start by writing the mixed numbers as improper. 2 times 4 is 8, plus 3 is 11, so I have negative 11 over 4, plus 7 times 8 is 56, plus 1 is 57. The denominators are different, so I start by writing the multiples of 4 and 8. And the first multiple of 8 is 8. And for 8, the first multiple of 8, which is a match, so my least common denominator is 8. So since one of my denominators is already 8, I only have to multiply the 4 by 2 to make its denominator 8. And I have negative 22 over 8 plus negative 57 over 8. Denominators are the same, so I can write this as negative 22 plus negative 57 over 8, which is negative 79 over 8. And if I take 8 and divide it into 79, I have a remainder of 7. So this can also be written as negative 9 and 7/8. So for 15, we have x over 12 plus x over 8. Even though we have variables in this problem, the process is exactly the same. So I'll take 12 and 8 and write the first 5 multiples of each one. And since I see a match at 24, I will stop my list and say that the least common denominator is equal to 24. And then on 12's list, 24 is the second number, so I multiply the numerator and denominator by 2. On 8's list, 24 is the third number, so I multiply the numerator and denominator by 3. So that I have 2x over 24 plus 3x over 24. Since both denominators are 24, we can take 2x plus 3x, add them together, and we get 5x over 24, which doesn't reduce, so this is our final answer. And for number 16, we have negative 3x over 8 plus 15x over 8, or 15x over 7. And to find the least common denominator, I write out the multiples of the denominators. After a while, you may be able to identify the least common denominator without writing out the list of multiples, and that's okay, but if you're ever stuck, always turn to the multiples and you'll always get the least common denominator. So I'm just going to make this list a little bit longer since we don't have a match. And the next multiple of 8 is actually 56. And we have a match, so the least common denominator is 56. So on 8's list, 56 is the 7th number. And on 7's list, 56 is the 8th number. So I have negative 21x over 56 plus 8 times 15 is 120x over 56. And if I add negative 21x plus 120x, I get 99x. And 99 and 56 do not reduce, so this is your final answer. For number 17, we have negative 2 over 3x plus 4 over 5x. And the x's are in the denominator, so we just take 3 and 5 and just write the multiples of 3 and 5. They both have an x, so you don't have to include the x in the multiple list. You can just write the multiples of 3 and 5. And I have a match of 15, so my least common denominator is 15. And on 3's list, 15 is the 5th number. On 5's list, 15 is the 3rd number. So I have negative 10 over 15x plus 12 over 15x. Denominators are the same, so I have negative 10 plus 12 over 15x, so that the final answer is 2 over 15x. 2 and 15 do not reduce, so this is your final answer. And for 18, we have x over 7 minus 3x over 5. So I write the multiples of 7 and 5. And I don't have a match up to 5, but if I extend the smaller list, or the list that ends with the smaller number, I now get a match at 35. So my least common denominator is 35. So on 7's list, 35 is the 5th number. On 5's list, 35 is the 7th number. So I have 5x over 35 minus 21x over 35. The denominators match, so we can write this as one fraction, 5x minus 21x over 35. And if we do keep, change, change, 5x plus a negative 21x is negative 16x. And if you try to reduce this, it wouldn't reduce because 16 and 35 do not have any common factors, so negative 16x over 35 is your final answer. So for number 19, we have 3 fractions, but again, the process will be exactly the same. We'll just have to write out a list of 3 multiples instead of 2. So I take all 3 denominators, 12, 6, and 9, and write the first 5 multiples of each. And if I look at my list, I don't have a match between all 3 rows, but if I add one more number to 6's list, I get 36, which is in all 3 rows. So my least common denominator is 36. So starting with 12's list, 36 is the 3rd number, so I multiply it by 3. On 6's list, 36 is the 6th number, so I multiply it by 6. And on 9's list, 36 is the 4th number, so I multiply it by 4. And when I take negative 5w times 3, I get negative 15w over 36 minus 42w over 36 plus 32w over 36. And I've changed all of my denominators into a 36, and now I can write one fraction all over 36. And if I write down my numerator, negative 15w minus 42w plus 32w, I take 2 numbers at a time starting from the left, and since I'm subtracting with negative signs, I do keep, change, change. So negative 15w plus negative 42w is equal to negative 57w. And then I bring down the 32w. And if I take negative 57 plus 32, I get negative 25W. So that I have negative 25W over 36. And if you wrote the prime factorization of each number, you would not have any common factors, so this is the final answer. And the last problem, negative 36 over 5W plus 8 over W, and W is the same as 1W, so if it helps you can write the 1 in. And when I list the multiples of 5 and 1, the least common denominator is 5, and I only have to multiply the second fraction by 5 because the first fraction already has a 5. So that I have negative 36 over 5W plus 40 over 5W. And I can now write this as one fraction. Which is 4 over 5W. And 4 and 5 do not reduce, so this is your final answer. In this lesson, you will learn how to multiply and divide fractions. So the directions are to multiply or divide and to write each answer in simplest form. So I will rewrite the fractions of 5/12 times 3/20. And to multiply, I'm going to take the numbers 12 and 20 and write their prime factorization. Since 5 and 3 are already prime, I'm going to leave the first fraction as just 5 over, and then 12 is 2 times 2 times 3, and then 3 is prime, so I leave that as 3 over 20, and 20's prime factorization is 2 times 2 times 5. Once you have all the numbers written in their prime factorization, you can cancel diagonally or vertically and multiply what's left. Since there isn't anything left on top, then your numerator is just 1. I have 4 2's in the denominator, so 2 times 2 times 2 times 2 is equal to 16. So my final answer is 1 over 16. Now this is not the only way this problem can be done. Another way is if you just take 5/12 times 3/20, and if you notice that 5 divides into 20 4 times, and 3 divides into 12 4 times, if you multiply the numbers that are left, you have 1 times 1 over 4 times 4, which is 1 over 16. So whichever method you decide to use, they're both correct. For number 2, 3 over 2, and then inside parentheses is negative 8 over 9. So when you have a number in parentheses, it just means multiply. So 3/2 times negative 8/9, and it doesn't matter which number you apply the negative to. I usually bring it to the numerator. And I'm going to take the number 8, and I'm going to write the prime factorization of 8. and the prime factorization of 9, and I rewrite the two fractions as 3 over 2 times negative 2 times 2 times 2 over 3 times 3. 1, 3 will cancel, one of the 2's will cancel, and I'm left with negative 2 times 2 over 3, which is negative 4/3. For number 3, negative 4 times 7/12. So negative 4 I will write as negative 4 over 1 times 7/12. And the only number that is not prime here is 12. So when I write the prime factorization of 12, I will rewrite these fractions as negative 4 over 1 times 7 over For number 3, negative 4 times 7/12 is the same as negative 4 over 1 times 7/12. So the prime factorization of 4 is just 2 times 2. 7 is prime. The prime factorization of 12 is 2 times 6 and then 2 times 3. So I'll rewrite these fractions as 2 times 2, and then the 7 is prime already, and then 2 times 2 times 3. The 2's cancel, and this negative sign in front is like having a negative 1 times 7. So my final answer is negative 7/3. For number 4, anytime you multiply mixed numbers, you always have to change them to an improper fraction first. So I take 1 times 8 is 8, add the 3 is 11. So negative 1 3/8 is negative 11 over 8 times 4 times 7 is 28 plus 2 is 30. So 30 over 7. And then I look at the numbers that are prime, which are negative 11 and 7, and I take the other numbers, 8 and 30, and I will write their prime factorization. So I have negative 11 over 2 times 2 times 2 times 2 times 3 times 5 over 7. And the only number I can cancel here is one of the 2's. So I just multiply out what's left. Negative 11 times 3 times 5 over 2 times 2 times 7 and I get negative 165 over 28. So you can leave your answer like this as an improper fraction, but since we started out with mixed numbers, I'm going to convert negative 165 over 28 back into a mixed number. And 28, if I multiply 28 times 5, I get 140, and that's the highest amount that 28 can divide into 165 without going over. I get a remainder of 25, so my final answer is negative 165 over 28, or negative 5 and 25 over 28. For number 5, we have negative 3/4 times negative 7 over 15 times 3 over 5. And the only numbers that I have to write the prime factorization for are 4 and 15. For number 5, I have negative 3 over 4 times negative 7 over 15 times 3 over 5. So the only numbers here that I have to write the prime factorization for are 4 and 15. The rest of the numbers are prime. So negative 3/4 is now negative 3 over 2 times 2, and then negative 17ths is negative 7 over 3 times 5, and then times 3/5. And when you cancel, you can only cancel diagonally. So this 3 will cancel with this 3, but these 5s do not cancel because they're not diagonal to each other. So what's left is negative 1 times negative 7 times negative 3, or that's just 3, For number 5, I have negative 3 over 4 times negative 7 over 15 times 3 over 5. So the only numbers here that aren't prime are 4 and 15. So 4's prime factorization is just 2 times 2, and 15's prime factorization is 3 times 5. So I'll rewrite the first fraction as negative 3 over 2 times 2, and then negative 7 over 15 as negative 7 over 3 times 5, and then just times 3 over 5. And you can only cancel vertically or diagonally. So the 3's cancel, but the 5's do not because they're both in the denominator. It's a numerator and denominator that you're trying to cancel. So there's not much to cancel here. You're left with negative 3 times negative 7 over 2 times 2 times 5 times 5. And that gives us a final answer of 21 over 2 times 2 is 4, and then 5 times 5 is 25. 4 times 25 is 100, so the final answer is 21 over 100. For number 6, we have 3 times negative 5/6. So the first thing I'm going to rewrite is 3 over 1 times negative 5 over 6, and then times 2 and 2/3, I take 2 times 3 is 6, plus the 2 in the numerator is 8/3. And I'm going to start with 6 is not prime. 6's prime factorization is 2 times 3. And then 8 is not prime, so I write 8 as 2 times 4, and then 2 times 2. So I have 3 over 1 times negative 5 over 6, but 6 is now 2 times 3, and then 8 is 2 times 2 times 2 over 3, and I will cancel these 3's, they're diagonal to each other, and these 2's, just 1 2 each, and I'm left with negative 5 times 2 times 2 and then over 1 times 3, or just 3. So if I multiply the numerator together, negative 5 times 2 is 10, times 2 is negative 20 over 3. And on this example, I'm going to change this to a mixed number. 3 divides into 20 6 times without going over, and I get a remainder of 2. So this can also be written as negative 6 and 2/3. For number 7, this problem has a combination of addition and multiplication. We have 8/3 plus 5/12 times negative 8/7. So if we follow PEMDAS, the order of operations, PEMDAS says that multiplication is before addition. So first we'll multiply 5/12 times negative 8/7. So if I take 5/12 times negative 8/7, I'm going to multiply these the same way I've been multiplying them for the past 6 problems. I take 12 and I write the prime factorization, and then the other number that's not prime is 8. So I can rewrite this as 5 over 2 times 2 times 3 times negative 8, which is 2 times 2 times 2, over 7. And 2 of the 2's cancel, so that I have 5 times negative 2 over 3 times 7 equals negative 10 over 21. So this is not the answer because we had an 8/3 in the beginning of the problem. We want to take 8/3 and add it to negative 10 over 21. So I know that 3 times 7 is 21, but just to confirm I have to find a least common denominator. So I start writing out multiples of 3. And I'm not going to get to my first multiple of 3 until I write out my 7th number. And since 21 is the smallest number that the two lists have in common, that means my least common denominator is equal to 21. So when you're finding a least common denominator, you want both denominators to be the same. And so I'm rewriting the first fraction as 56 over 21 plus negative 10 over 21. And the purpose of doing this is so that I can combine the numerators but keep the denominator as 21. So I have 56 plus negative 10 over 21 is equal to 46 over 21. And 46 over 21 is my answer as an improper fraction. But if I take 21 and divide it into 46, 2 times 21 is 42. So I get a remainder of 4. So this could also be written as 2 and 4 over 21. So for number 8, now we're getting into fractions that have variables. So I'm going to do this the same way. I'm first going to rewrite this as negative 4x over 7 times negative 3x over 18. And the numbers that aren't prime are called composite, so I'm going to take my composite numbers of 4 and 18 and write their prime factorization. So negative 4x over 7 is negative 2 times 2 times x over 7, and then times negative 3x over 7, or over 18, is 2 times 3 times 3. So we get one of the 3's to cancel, one of the 2's to cancel, so that I'm left with negative 2 times x, and then be very careful not to forget this negative in the second fraction, so it's times negative 1 times another x over 7 times 3. So to finish this, you want to multiply the numbers together, and then both of the x's have a power of 1. The rule is that when you multiply variables that are the same together, you add their powers. So we have negative 2 times negative 1 is positive 2, and then x to the first times x to the first, we add the powers and get x squared over 21. So the final answer is 2x squared over 21. For number 9, negative 7x to the fifth over 12 times 5x over 49. And I start with the first composite number, which is 12, and I have 2 times 6 and then 2 times 3. 49 can only split up to 7 times 7. So I have negative 7x to the fifth over 2 times 2 times 3 times 5x over 7 times 7, and only a 7 will cancel, and I'm left with this negative in the numerator of the first fraction, so it's negative 1 times x to the fifth times 5 times x to the first over 2 times 2 times 3 times 7. And I multiply the entire numerator together. I have negative 1 times 5 is negative 5. And then I'm multiplying the x's together, but the rule is to add the powers of 5 and 1, so that I have x to the sixth. And then 2 times 2 is 4. 3 times 7 is 21, and 4 times 21 is 84. For number 10, negative 8x squared y, and I'll put a 1 here to remind myself that it's y to the first, over 5 times 35 xy is x to the first, y to the first, over 16. So I start with 8. 8 is composite, so I write the prime factorization of 8. And then my next composite number is 35. And 35 is just 5 times 7. And then 16. So negative 8 is negative 2 times 2 times 2. And then I have x squared y to the first over 5 times 35 is 5 times 7, x to the first, y to the first, over 2 times 2 times 2 times 2. and we have 3 2's that cancel, a 5 that cancels. Just don't forget about this -1 in front of the first fraction. So -1 times x squared times y to the first times 7 times x to the first times y to the first over 2. And if I multiply -1 times 7, we get -7. And then the x's, we add the powers of the x's. 2 plus 1 is 3. We add the powers of the y's. 1 plus 1 is 2. So our final answer is -7x cubed y squared over 2. For number 11, now we're dividing, and the rule with division that you want to change the second fraction to its reciprocal and also change the division symbol to multiplication. So it's -2/3 times 9 over 8. And to solve these problems, it's exactly the same as what we were doing earlier. You just want to remember to change division to multiplication and take the reciprocal of the second fraction. So I write the prime factorization of 9 as 3 times 3, the prime factorization of 8 as 2 times 4 and 2 times 2, a 3 cancels, a 2 cancels, and I have -1 times 3 over 2 times 2, which is -3 over 4. And for number 12, we have 2 mixed numbers, so I want to change this to improper. 1 times 8 is 8, plus 5 is 13, so I have -13 over 8. And then first I'm going to write the second fraction as a mixed number before I change it to multiplication. 4 times 12 is 48, plus 7 is 55, and I change the division symbol to multiplication and take the reciprocal of the second fraction. So the prime factorization of 8 is 2 times 4 and then 2 times 2. Of 12, it's 2 times 6 and then 2 times 3. And for 55, it's just 5 times 11. And the only thing that cancels here is just one of the 2's. So I'm left with -13 times 2 times 3 So 2 of the 2's cancel, and I'm left with -13 times 3 over 2 times 5 times 11, and -13 times 3 is -39. 2 times 5 is 10, and then times 11 is 110. For number 13, I take 1 times 15 add 1 is 16 over 15, and then divided by 12. The only division here is with the number 12. So I'm going to change it to multiplication and write this as 1/12. And now we're back to multiplication. So I take 3 times 4 is 12, plus 1 is 13 over 4. And now I can write the prime factorization of each of these numbers that are composite. So 16 is 2 times 2 times 2 times 2. 15 is 3 times 5. And 1/12 is 1 over 2 times 2 times 3 over 13 over 4 is just 2 times 2. And I have 2 2's that cancel with these 2's. And then the rest of the 2's cancel with these 2's. And that's about it. And we're left with 1 times 13 over 3 times 5 times 3 which is 13 over 3 times 5 is 15, times it by 3 is 45. 13 over 45 is the final answer. So now we have one with a variable, a cubed over 2 divided by 11 over 2a. So I change the division symbol to multiplication and take the reciprocal of the second fraction. And all of these numbers are prime. The only thing I want to add is a 1 here to that a as a reminder that it's 2a to the first. So I have a cubed times 2a to the first over 2 times 11. And I can cancel the 2's. So a cubed times a to the first over 11. And the only remaining step that you can do here is add the powers of the a, and the final answer is a to the fourth over 11. And the last problem, negative 12m cubed over 5. I change my division to multiplication, take the reciprocal of the second fraction, 20m squared over 3. And I take the number 12 and the number 20 and write their prime factorization. And negative 12 is negative 2 times 2 times 3 times m cubed over 5 times 20 is 2 times 2 times 5 m squared over 3. So one of the 5's will cancel, one of the 3's will cancel. The 2's do not cancel because they're horizontal to each other. They have to be diagonal or vertical. And we're left with negative 2 times 2 times m cubed times 2 times 2 times m squared. And there's nothing left in the denominator, so it's just over 1. And if I multiply all of the 2's together, I have negative 2 times 2 is 4, times another 2 is 8, times another 2 is 16, but it's negative, so negative 16. and then you have m cubed times m squared. You want to add the powers of m, not multiply them. M to the fifth. You can write this over 1, but you don't need to. So the final answer is negative 16 m to the fifth.